How are you doing, 171 guys? Hope you guys are doing good. Want to continue on a little bit on differentials. I want to walk you guys through a Ford 9-inch. This is a kind of a unique rear differential. This is used by Ford Motor Company. It's also used by a couple other manufacturers, a basic design to this thing. It is significantly different than some of the stuff that you guys have already seen that I've shown you. But this assembly is a little unique in the way it's serviced and the way it is assembled and how you make the adjustments. In the last video, I talked about shim placement for the differential carrier. And I said your preload shim and your shims used to adjust backlash are actually either on the inside of the bearing or on the outside of the cup to preload the carrier or put crush on the carrier and potentially set the position in which the ring falls within the pinion to establish what they call backlash. And again, that's the backlash measurement we were talking about in the last video. On the Ford system, the Ford 9-inch, and I believe Toyota uses this, and some other manufacturers will utilize an adjuster. This is actually a threaded adjuster. There's one on either side that's actually used to position the carrier within the case. So what you would basically do in this particular case, during our setup procedure, we can actually measure our backlash and determine if it's out. What you would do is take these locking fasteners off. These just simply become removed from the carrier itself. These are just little tin dealios that actually lock the adjusters in so the adjusters don't pivot. And then at that point, this is free to move. You would use a tool called a spanner wrench. This is a type of spanner wrench. You don't have to actually use this one. And you'd actually turn the wheel in either direction to move the carrier. Now, in this particular case, if I wanted to move the ring towards the pinion in this direction to reduce some of the backlash, the first step would be moving this outer adjuster, the pinion side adjuster, and basically turning this counterclockwise. So this is going to be turned counterclockwise in this direction. And you can note the number of turns, and that will give you the movement or the freedom to move this adjuster up, which raises the entire carrier assembly, bringing your ring tighter to the pinion. In that particular case, if I was going to make this adjustment, I could actually easily turn this adjuster, pushing the carrier up. If I can get this in here, pushing the carrier up into the pinion, reducing our backlash. The issue would be at this point is I've moved this adjuster up, but I need to achieve preload on this bearing. So even though I've made the adjustment, I still need to achieve preload. In most cases, what you're going to do is you're actually going to get to zero end play, zero preload. I can easily do that with my fingers. I'm actually turning this down, and I bottomed both cups, both adjusters together, and I can feel that I'm getting some tension on here. You're going to note the position of the fastener with the hole, and in most cases, you're going to pull it like maybe 1 or 2 holes over. It depends on the size of the bearing and whatever the manufacturer procedure is. But at that point, what you do is you just indicate where it is aligned with the fastener hole, and then you turn it maybe 2 holes over. And that would achieve the proper preload. And again, that's not a specification. That's something you're going to need to look up. That's why I remember it's really important to follow manufacturers' procedures when you set up these axles. But again, in that particular case, what I just did is I decreased my backlash. I've moved my ring closer to the pinion in this assembly, and that's achieved a better adjustment for me. Your final adjustment on backlash would be mounting a dial indicator, such as this, on the carrier and on the top of the ring. And what I usually do is I try to place it where I can get to the top of that actual ring. It's actually set up in here, and actually I'm going to see if I can tip it a little bit so you guys can see how I got that set up. Maybe you can see how that's set up. It's a little bit out of view. Let me bring it down a little bit. So I'm basically going to rock the pinion or hold the ring, but rock the pinion back, or hold the pinion, rock the ring back and forth, and look at the movement on the dial indicator. And that would represent my backlash. So I'll tip it a little bit so you guys can watch. I'll hold this, rock it back. Whoops, got to get the gear. And at that point, that movement would be my backlash. 8 to thousandths, 8 to 10 thousandths is probably what you're looking for. If it's too tight, you're not going to get some lube between the bearings, lube between the two gears. So you got to make sure you have some lubrication. You also want to give yourself some room for expansion, because once this guy gets hot, that backlash is going to decrease. So once you drive this car and you put some load in here, put a little heat in here, what's going to happen is you're going to end up getting a little hotter ring, a little hotter pinion, things are going to expand, and that backlash is going to tighten up on you. Okay? So again, tight is good in this case, but I don't want to be so tight to the point where I actually have no clearance once the thing's hot. You actually get a high pitch whining noise when that occurs. So at that point, you can take this off. You can put your locking mechanisms back on, and they just go in and engage. Couple advantages of the 9-inch rear axle we talked a little bit about. The 9-inch axle actually has, you can kind of see it in this picture right here, but you can actually see the end of the pinion right here. There's an additional pin or additional bearing assembly on the end of that pinion. So you're going to see that there's a third bearing. So in the 9-inch axle, there's 3 bearings, one that supports the end of the pinion. So again, high performance application. This was very, very popular. The pinion is actually set in its own carrier. So the pinion is actually bolted on the back side of this. So you can actually set this up outside of the case. You can bolt this back in. This particular area right here, this spot right here, is gasket surface, but it's also the pinion depth shim surface. So you're going to put a thicker, thinner gasket in here, which raises and lowers the pinion in the ring, so it actually sets your pinion depth. I'm making a mess on my floor here. But that's kind of how that works. Okay, so that's a little different. And again, we talked about pinion setup. Pinion bearing preload on this guy is controlled with a shim. You would actually turn this nut, rotate this nut using a tool like this. It's called a torquometer. And obviously with the carrier out and the ring out, you could actually turn this and actually see what your preload is. If it has a stacked shim assembly and bearing preload, what you would end up doing is just putting the old shims in, measuring turning torque. If it's not correct, if it's too loose, you put a thinner shim in. If it's too tight, you put a thicker shim in for bearing preload. If it uses a crush collar, you're going to hold the yoke, turn the nut until you achieve the proper preload you're looking for. And again, that's bearing preload on the pinion. You'd have to have the carrier out. You cannot be turning the ring while you're turning the pinion for setting up pinion bearing preload. We've already talked about that in previous videos. Okay, so that's pretty much how a 9-inch sets a setup. 9 inches are cool. The coolest part of a 9-inch is if you're drag racing and you don't like your gear ratio you're running, maybe you're running a 1/4 mile track, and then you decide for the heck of it you're going to run an 1/8 mile track, you're going to want to change your rear pinion ratio or final drive ratio. What you're going to do is basically just pull the axles out, unbolt this from your carrier or your differential housing, slide it out, slide another one in, bolt it in, and go racing. It's very, very popular for race car guys because they can have several of these in their trailer. Depending on the track they're running at, they can actually put a different rear end in. Guys who run race cars on tracks, this is a pretty hot setup because you can actually run around with different gear ratios in the back of your trailer depending on how big the track you're running on that weekend. So, but again, this is 4 9-inch adjustable dealios. Pretty cool. You don't have to order any shims. Nice assembly. Pretty cool little setup. Okay, we'll talk to you later. And again, this is the third, I think it's the third, maybe even the 4th video on differentials that I did this week. I apologize for putting this sucker up on Friday, but I wanted to make sure I got this one done before the weekend. So, all right, you guys have a great weekend. We'll talk to you.